I'll get back to the almost later, but first, how do we program a Christmas tree? Matt Parker from the YouTube channel Stand Up Maths did all of the hard work for this. He bought LED strips with 500 individually addressable lights on them, wired in extra power supplies, and mapped the 3D location of each light by turning them on and off one by one and plotting their positions in camera image space. He did this for 4 directions to cover all 3D axes. He even compensated for occluded lights and bad measurements. Check out his videos for details. This let him run Python programs on a Raspberry Pi Zero to drive patterns through the lights in 3D space. In his case, a simple plane moving vertically, but he added variation by randomly rotating the tree to slice the lights at different angles. However, at the end of that video, he invited his audience to send their own examples, and the resulting video on his second channel has more views than his main channel. This resulted in a third video, where he further refined the process by creating a standard animation format that he called GIFT, Geographic Information for Trees, so that anybody could bake out an animation using the technology of their choice, and it would definitely play on the tree. I left the video with this message.
You then send back the CSV file to me, and at some point in early January, I will run them all.
So I thought I would give it a go. My tool of choice for programming the Christmas tree was to use the P5.js web editor. P5 is essentially processing for JavaScript. It creates a simple API to interface a lot of JavaScript libraries, most importantly in my case WebGL. If you're familiar with Arduino, it is very similar, with a setup and a draw function, which is the equivalent of loop in Arduino. I firstly had to get one of the examples working to draw the Christmas tree in 3D and run an animation on the simulated lights. To do this, I read all of the points into memory in the setup function, and then run through them in sequence once per frame in the draw function. I created a 3D sphere for each light using the position from the positions file, and set the color from the data in the animation file. We use the frame count variable from P5 to work out how many frames have already been displayed, which lets us look up which row of the animation file to look up. Next, I had to make sure that I could export a file in the GIFT format. P5 has a general table object that can be used to store row-based data and has a CSV option for exporting, which made this quite easy. My first attempt at animation was to generate a pulse travelling outwards from the centre. We test whether the current point is inside an expanding sphere and colour it red if it is inside. This is followed by a second expanding sphere test with a delay, which turns them off again. I made a few other examples as well, pulsing the lights and picking a random colour each time we pulse, playing with the timing by flashing Morse code, cycling through HSV space based on the distance from the origin, and the same thing spiralling up the tree, or just rippling upwards through it. I also interpolated between colours at the top and the bottom of the tree, and finally thresholded noise to make some random patches of bright white light that move through the tree. One of the coolest features of P5 is that it supports fast Fourier transforms, so that you can make the Christmas tree into a full graphics equalizer. This is using the Stand Up Maths theme tune as a source input waveform. There were also some hardware constraints that I did not take into account. The actual lights do have physical constraints about how fast they can switch. There are also power constraints, which means that you cannot have too many lights on at full brightness, especially using all RGB to get white at once. Well, I'll never know because Matt Parker never made that video. But there is still time. Matt, if you could give us a new positions file, we could regenerate all the animation data very easily. I realise that calibrating a new Christmas tree is not a small task, but I'd love to see this running in real life. All of the animations from all the contributors are available in this GitHub repository. And however you decorate your Christmas tree this year, Merry Christmas and a Happy New Year.